Welcome to this channel. Today I want us to discuss this question, and the question says that we should show that the limit of this is equal to e. Now, to solve a question like this is how you start. Okay, you will pick your x. Now you will change this x to 0, which is what is here. Okay, so let's see how that goes. We have 1 plus x becomes 0, which is the power of 1 over 0. So what is 1 plus 0? That's 1. What's 1 over 0? That's infinity. Now in maths, when you see 1 raised to the power infinity, we call it indeterminate. So what is the meaning of indeterminate? Indeterminate means that we still have more work to do on this, and we can get the answers later as a finite number. That's not indeterminate. That means that it has an answer but not directly. So how do we do this? At this junction, you're going to now do something. You say let y equal the question, but don't write the limit, just write the question. Okay, so when you now get here, you're going to take something that is called natural log ln of both sides. So you take ln of y, and when you're done, you come again and got ln again. You got ln of this one. So basically what we're doing is this. We're taking natural log of both sides. We're taking ln of this and ln of that, okay? So ln of this and ln of that. I think it's clear. Now, there's something I want to show you. Now, anytime you have ln of something, let's ln of y, it means in reality log to the base of e of that y. So log is involved, and because log is involved, I can use the laws of logarithm. Okay, so let's do it. Now I'm seeing ln here. That means log is involved, so I can use the laws of logarithm. Okay, so what I will have now is this. This power will fall. That will give me 1 over x. Then I will have my ln. Then I'm going to continue with 1 plus x. You might be wondering, why did this power fall? The power is fallen, or the power has fallen because this is log. I mean, this contains a log, and because this contains a log, I can use the laws of logarithm. According to the laws of logarithm, a power like this can fall. Do you understand? So let me now solve this further, just to give me the same ln again. Same ln, but this time around, I want to have 1 plus x divided by x. Now you might be wondering, why did I say divided? Because it's obvious that this x is down, so I can just put it down. Okay, then your ln is there. Do you understand? So at this junction, you can introduce your limits. You know, I didn't use it before, but now I want to use it. I need it now. So put your limits for the left and your limit for the right. So for the right, we have this. So that right, we need to do some work on it, okay? But the left, we can still ignore it for now. So how do I do the right hand side? Now this is my x. So what I will do is this. This is my x. I will change it to 0, which is what is here. So let's do it. We have ln. This is 0. So 1 plus 0 will give you 1. This one is 0 already. What is ln 1 in calculator? Ln 1 is 0. So I'm seeing 0 over 0. And when you see something like this, of course, it is also an indeterminate. Okay, it's also an indeterminate. But this kind of indeterminate is very special. So I'm going to use a particular law, and it's called L'Hopital rule. Don't mind my pronunciation, please. It's called L'Hopital rule. I don't even know if this one is right or wrong. I don't know. But what I know is that the law is called L'Hopital rule, and it can only occur if you have 0 over 0 or infinity over infinity. But for this case, 0 over 0. Okay, so how do we do it now? I have 0 over 0. I'm going to use L'Hopital rule. So let me turn the paper to the other side. So I want to write this. So I think we're here for now, and everything so far, they basically align with what's out here. And let's confirm if I'm right or wrong. Yes, see where we are, and I think it tallies, right? Okay, that's good. So let's continue please from here. So with this now, so what I would do is this. You know, I've already established the fact that this is 0 over 0, and I want to use L'Hopital rule. So what is L'Hopital rule? According to that rule, what you would do is this. You're going to do derivative of this up, derivative of the up, and when you are done, you do derivative of the down. So derivative of the up, and when you're done, do derivative of the down. Do you understand that? So let me do derivative of the up, okay? Now derivative of the up, how do I do that? So let me do that in a separate paper. Okay, so now when someone tells you ln 1 plus x, find derivative of this, how do you do it? The first thing you would do is that you're going to isolate this. Do you understand? So you're going to do basically derivative of this one. That will give you 1. Then you will divide by this. So let me say it again. Just isolate this. Find derivative of this. That will give you 1. And divide by this again. So we have 1 over 1 plus x. And we're done. So just bring the answer down. Okay. So right now I'm saying limit x approaches 0. So I've done this. I got 1 over 1 plus x. What about it down? If we differentiate x, what will it give you? It will give you 1. So we can divide by 1. It's not useful. So right now we're here. So we can just say that fine, our x can be changed to 0, and let's see what happens. So what we have now is 1 over 1 plus. So we'll put 0 here. So the answer is 1 over 1, and we get a 1. So remember that I didn't write the left hand side, so I'll write it now. I mean here, I didn't write this guy, so let me write it back. So I'm having limit x approaches 0, right? Now remember, I've done all this and the answer is 1, so put 1 here. Okay, fine. Do you know that you can do something very surprising here? Let me show you. This whole thing now, I can rewrite it. The ln can come out. Can come out. The limit can go in. That's limits of y. X approaches 0. Can you see what I'm doing? Fine. So the ln can go out, limit can go in, and we are done with this. Is equal to 1. Can you see that? So I can write back what I wrote here. Let me write on the other page. So I have this. So ln is out, limit is in, x approaches 0, and the answer is equal to 1. And remember what I told you before, that anywhere you see ln of something, it's log to the base of e of that thing. Can you see it? So that means I can just remove this and write what? Log to the base of e of this. Can you see that? Of this limit. Can you see that? Okay, is equal to 1. So from here, from the law of logarithm, I can do change of base. So this one will just come out as limit of y, x approaches 0, while this e will go here as e raised to power 1, and that is e, and we are done. That's the answer. That's 0. Okay, we're done. So that's it, and I'm sure you know that this your y is this. Your y is this. Your y is 1 plus x raised to power 1 over x, and that's all. So it's proved. So thank you and bye.